part B, definite integrals involving substitution. If you remember, we have the method using substitution, and it's just a short way to solve with definite integrals. You just need to change the boundaries. If you remember, we changed the different variable and these 0 and 1 with respect to x, but when we change the variable, we have to also change the boundaries. But it doesn't have to be like this. When you calculate the integration, you can calculate with respect to x at the end, then put 0 and 1. It's just a shortcut, kind of. Okay, let's review what says with substitution. What do we call here? If you remember, x cubed plus 1 equals to u, and we see that 3x squared dx du, and we see that I don't have 3, so I can rewrite the second part as du by 3. So what it will be, e to the power u du by 3. Now look at here, I don't have x, everything with respect to u, so I can change also the boundaries. At first, boundaries start with 0, so I have to do with respect to u, so it will be u1 and u2, between u1 and 2. So how do we do it? Just in the first part, what we call u, we replace instead of x 0, 0 cubed plus 1 will be 1. So when it's 0, the lower boundary with respect to u is 1. And when it's 1, 1 cubed plus 1 will be 2. So the lower upper boundary will be 2. That's it. So let's rewrite in a more proper way. 1 by 3 goes out, so I have EU du between 1 and 2. So it will be, we know that 1 by 3 EU e to the power u between 1 and 2, and we just first put 2, 1 by 3 e squared minus, let me put the bracket here, not to write one more time, e to the power e. So this one the answer. But when you calculate this one, you can here, without changing the boundaries, you could replace what was u, x cubed plus 1 at the end, and go with the original boundaries. Okay, not to do double job here, we can change the boundaries too. Let's do one more example here. Okay, with substitution method, we will call 1 minus sine x equals to u, so we take the derivative. It will be minus cosine x dx du, but we have just positive, so it will be cosine x dx plus minus du. Okay, so our integration will become minus du divided by u. And here the boundaries, let's use the method which book says, let's change the boundaries. When x equals to 0, I put it here in the first expression. So it's 1 minus sine 0. So what sine 0 is 0, it will be 1. So the lower boundary will be 1. And the upper boundary will be, when I put pi by 6, 1 minus sine pi by 6. We know that pi by 6 is 1 by 2, 1 minus 1 by 2 is 1 by 2 again. So it will be 1 by 2. Did I do? Yeah. So let's do it. What will be? Okay, if you write properly, minus 1 by 2 du by u, so we know it's equal to minus ln u from 1 by 2. So what will be the result? Minus ln 1 by 2 minus ln 1, and we know that ln 1 equals to 0, so it will be minus ln 1 by 2, or we can write just ln 2, because to the power minus 1 goes out, it will be positive ln 2.